Welcome back, friends. Let's continue working on this force outboard and see if we can get it back together and get it running. So since we already have it down this far, I decided we might as well go through all three cylinders. So we're going to go ahead and do that. I want to run the deglazer through all three, check the ring gaps on them and everything. Make sure there's nothing weird on either of the other two pistons, no aluminum transfer starting or anything like that. But to get a good angle on this bottom one, we have to get this bottom cowl off here, so we're going to go ahead and do that first. Next, we need to undo all of these electrical connections, but before I do that, probably should have done this a while ago, but I'm going to go disconnect the battery. And it looks like this is all just silicone on here, just to try and waterproof the connections, I'm guessing. Normally I would expect like dielectric grease or something like that, but I guess silicone works too. Last two connections here, I think I'm just going to go ahead and cut these. And this is what we're looking at for bolts here. There's probably like 10 or 12 of these little guys all the way around the outside of the perimeter here. Thought we'd be able to get past the plate with all the coils and CDI and electronics on it, but looks like we're not going to, so we got to take that off too. Alright, it's unavoidable. Tried everything I could. I got to pull the flywheel and the stator off. That just seems to be the smartest way to do it. The hole in the bottom of this cowl is just not big enough to get up and around and everything. Tried pulling the starter off on the other side. Doesn't help. So we just got to pull the flywheel, and I think we're going to have to pull the stator off because that's going to come off with all the electronics. I don't see any disconnects in there or anything, and I don't want to cut those wires and splice them. I'd rather just leave them whole. So I guess let's get that off there. This has turned into an ordeal. Let's see if we can bust this loose without breaking any bolts. Let's try the other forward. Really don't like that they didn't allow for bigger bolts to be used with this puller. I feel like those are just going to snap. Probably already stretching. Yep. Washers are bending anyway. Try it again. Heavier washers on the bolts this time. Still, other forward. Well, when all else fails, I think time is the answer. So we're going to let that sit with pressure on it for, well, probably a day or so. Let it sit overnight, see if that makes any kind of a difference. Can always try heat if I have to. I just don't want to wrench on those bolts anymore. Being only 1/4 inch, I just don't know how much they can take before they're going to snap. So definitely don't want to deal with that. Also going to go hit the internet and see if there might be something I'm missing, but I mean that should just pop right off of there. So she's been sitting here for about 2.5 days now with tension on it, still hasn't popped loose, so time to break out the torch. There she went. Alright, we should be free to get all of the electronics off here now. This is a freaking rat's nest. I did not expect this many wires here. Well, not quite. 2 more. Like I said, it's a rat's nest. Thought I had all of them. Not quite. Take 3. Son of a bitch. Still. I forgot about the timing advance. Take 4. There we go. Alright, that had to have given us enough room to get this off. Let's try it. Fuel pump's gonna make a liar out of me. Alright, let's take the fuel pump off. How can we get it off? Just barely. We'll take that. Alright, so now we can get a much better angle at this bottom cylinder. And then the other thing too, I really want to be able to get in here and get all these plates off on both sides, so I can really get in there and try and clean the block out after I hone it and just try and get all the debris out of there. I think that's going to be kind of important. While we're not doing this, exactly the right way, I still want to, don't want to completely half-ass it. And then, when you get down to it too, I'm sure this is probably why a lot of people like 2-strokes, well, 2-stroke outboards over 4-strokes, because I mean, this is an 85 horse, at least it's rated at 85, and I think the horsepower ratings changed in like 83 or 85. They used to rate them at the crankshaft, and then after like 83 or 85, like I said, then they started rating them at the prop. And this is an 88, so it should have been rated at the prop, but there's a big debate on whether or not Force actually ever rated any of their motors at the prop, just because they typically don't hold up to other motors that are rated at the same horsepower. Take a look at this 60 horse 4-stroke over here. Granted, none of the parts are taken off of this, and the camera probably doesn't really do it justice, but just from a statistics point of view or a specifications point of view, this 60 horse weighs, I think it's actually like 5 pounds more than that Force does, and that's an 85 horse. So I think this one is like 255 pounds or something like that, according to iBoats, and then that Force is like 250. So they're really close in weight, but I mean, for the extra 25 horsepower, I guess power to weight ratio is more than likely always going to be better on a 2-stroke. So anyway, let's continue looking at this turd and breaking it down further, cleaning up what we need to clean up, and then start the reassembly process. Well, I just pulled out that number 1 piston, and we're going to grab the ring off of it here, top ring, and we're going to check some ring gaps and see what we're looking like there, if I can get this thing out of here without snapping it. Quick little interesting fact about these rings: you can see they have a beveled edge on the top here, and that beveled edge goes up. And the theory behind that is that when your fuel charge is ignited, the expanding gases will get down in and make contact with this beveled edge and have more surface area to push the ring out against the cylinder walls and make a better seal, and I guess kind of help out your compression ratio. But that's just theoretical. I have no idea how well that actually works, but just thought I'd point that out. So let's go pop this in the cylinders and measure our ring gap and see just how far out of spec we are. So this top cylinder has not been touched with the deglazer yet. So let's pop this in here and just see what our ring gap looks like. So spec on this is 6 to 16 thousandths for a gap, so I'm gonna guess we're already outside of that. We'll start with 18. Yep, 18 fits right in there. 22 slides through. 25 is a no-go. So 24 just barely fits. So we're probably about like 23 and a half, 24 thousandths for a ring gap. And like I said, upper end of factory spec is 16 thousandths. I don't know if that's on a new bore or a worn bore, but if you remember, our shitty Harbor Freight gauge was reading about 90 psi, so I'm betting that's more around like 120, to be honest with you. It's definitely over 100. I know that gauge is way off. But, so we're like 8 thousandths over the top of the specified ring gap. But that really didn't seem to be making that much of a difference. So, I'm not too worried about this cylinder, or the bottom one really. We're just going to toss the rings back in there and run it. Probably wouldn't be a bad idea to put new rings on all 3 cylinders, but I think we're just going to go cheap and just see how long it lasts. Really, I don't have the correct tools to actually measure bore taper or out of round. Like I said, I just have some crappy telescoping bore gauges, and then I can check ring gaps, and that's really all I'm looking for here. I don't want to be just crazy blown out of proportion. But I mean, if this top cylinder was running, and hitting about 120 psi with a ring gap that's about almost 10 thousandths over, I'd be surprised if this one's much different. So let's try 26. Yeah, so 26 thousandths actually doesn't fit in that middle cylinder. So really not that far off from where the other 2 cylinders are. I'm assuming number 3 down here is about the same as number 1, but we'll check that one once we get that piston out. And 25 barely squeaks in there. So we're still about, we're less than 2 thousandths larger on the center cylinder. I'm sorry, you guys can't even see that. Less than 2 thousandths larger on the center cylinder than we are on the quote-unquote stock cylinders yet. So truthfully, I really don't think this is going to run all that bad once we put it back together. It's not a race engine. We just want to be able to pull a tube around. So with that in mind, I think we're going to be just fine here.
I think you're going to be okay here.
So with a ring gap that's just a little bit on the large side like that, I think, worst case scenario, what we're going to see is just a slight drop in compression, and then the engine will run a little bit worse and probably carbon up a little bit faster. But these force engines ran so shitty from the factory that you're supposed to decarbon them like twice a year anyway, I guess, and that is to avoid what we saw here on this cylinder, stuck rings from the carbon buildup. And everything else. So I guess all the guys in the forums say that you are supposed to decarb them twice a year. So if I'm doing that as preventative maintenance, I really don't think that extra couple thousandths on the ring gap is going to be that big of a deal. But I guess we'll find out. Last piston coming out. And the rings are actually free on that one too, so that's good. Piston doesn't look too bad. Let's set this guy down. Found that one of the easier ways to get the rod bearings out is actually through the front. So there's 2 more. And if you're trying to retrieve those needle bearings, I found out too late, but you really should not use a magnet because they're super easy to magnetize. And then if you put them back in that way, they'll sit there and collect normal wear particles and wear them out faster. So it looks like I got 5 out, which means there's 11 more in there yet. Should be 16 total. That bottom bore doesn't look too bad. It looks pretty similar to the top bore. I don't know if you can tell or not, but there's still a little bit of cross-hatching left there. There's also a bit of scoring, nothing that I can catch a fingernail on, and there's also a little bit of pitting, which is why I wanted to break this all the way down and at least run the deglazer through it just to clean that up a little bit before we throw it back together and send it. Well, things just keep escalating here. I'm not sure if you'll be able to hear this or not, but listen closely. So you might have been able to hear what kind of sounds like sandpaper, and Well, I'm pretty sure some of the honing material, despite my best efforts, got down into the crank bearings. So I think we're going to look at just pulling the power head and at least taking it apart to clean everything out and then checking everything over on the inside of there. Yeah, I really, like, especially now, it does not pay to just put it back together like this. At the very least, we got to clean it out. So we're definitely going to pull the power head, and I'm buying a full gasket kit for this thing anyway. And for as far as we've had to rip this thing down so far, there's really, like, there's not much left, at least from what I can see, to take the power head off. It looks like we're just looking at the bolts that connect the head to the lower unit. So, you know, it really shouldn't be that difficult, but famous last words. So it's looking like that's what we're going to do. I think that's the smart thing to do. And I mean, we have all winter to do it, so it's really not that big of a deal time-wise. And then that way, hopefully, we'll be able to actually get some use out of it next summer. And I mean, especially if I end up taking it to a machine shop and getting it bored out, I think we'll probably get quite a few more years of use out of this thing. Yep, project continues. And hopefully you can see that there. We do have a pretty deep vertical score there on the back of this cylinder, and then another one on number 3. So those really should be bored out. Those are only going to be more of an issue in the future. So we'll have to take that into consideration and just see what we decide to do. So all things considered here, we're talking about at least $150 in machine work to get this thing bored out. $100 for a gasket set. And then at that point, I really should, well, yeah, I'm going to have to get all new pistons and rings. And last I checked, pistons for this were about $100, $120. So all said and done, to rebuild this thing now with the machine work included, we're looking at about $600. So we jumped up from 120 to 600 real fast there. My gut's telling me we're not going to do the machine work on it, and we're just going to rip it down and clean it out. Smart thing to do, of course, would be to have it machined and then put it back together the right way, but in the end, again, still just a force outboard. I'd rather save my money and put it into something that I'm going to trust a little bit more than this thing. I'd really like to find a newer Johnson or Evinrude or even another 4-stroke Yamaha, maybe a little bit bigger than the F60. Regardless, I'm trying to stay in the 70 to 80 horse range, so we'll just see what happens there. The other plus side to taking off the power head and splitting the case is then that reinstalling the rod bearings becomes a breeze, and I'm not fighting to try and get them in through the cylinder or in through the intake there. So plus side there, and again, we're already down this far, really not going to be that much more work. Well, we pulled the rear cover off the mid leg there. There's just 3 bolts on each side. And then there's a total of like 12, I think, fasteners holding the power head to the mid leg. I think there's 3 bolts on this side in the front, 3 on the other side, and then 3 studs here. 2 studs on the opposite side, and then there's 1 hidden one up underneath here. But it looks like those are all out now. We should be good to go to try and break this loose, and I'm betting that's probably going to be a bear, just like the flywheel was. I don't know if there's any really good place to give this a couple of stiff whacks. Oh, many swings of the dead blow later. It looks like we are officially loose. So let's get the cherry picker hooked up and see if we can pull this thing off. Got a piece of flat bar that just happens to have the right sized hole in it, so we're gonna try and use that as a lifting eye, since US Marine wasn't kind enough to put one on the motor for us. That should be plenty sturdy. A little bit of extra help with the pry bar, and she seems to be slowly but surely making her way up. So do you remember like way back at the beginning of all this when I said this was probably just going to be like an idle adjustment or, you know, at worst a head gasket? Yep. Damn it. Well, now you should be able to hear this bearing a little bit better. Hear that? Definitely needs to be taken apart and cleaned out. So we definitely have a lot more work to do here yet, but with the case split now, I think this is a good place to take a pause. I got to get all this crap cleaned up, get some of my tools wiped down, and there's a lot of dirt on the outside of the power head that kind of made its way down into the workspace now, so just want to get that kind of cleaned up, that way I'm not battling more crap making its way into the engine when we're trying to reassemble it. So I'll get back with you guys when I'm ready to clean out that crank bearing. I'm not 100% sure how those come apart yet, so I got to go figure that out as well. Until then, thank you so much for watching, and we will see you in the next one.